Alright, this is the 6.3 lesson. So go ahead and pause the video and try the warm-up on your own. The warm-up goes over past skills that we've done that will help you with this lesson. So take a moment, try it, and then come back to check and see how you did. Alright, so for the first section, you're looking for what they have in common. So both of these numbers are divisible by 7. They don't have any variables in common. So when I divide out 7, there'd be 2x left over for this, and there'd be 3 left over for the second term. Okay, so take a moment just to double check, were you able to find the common factors? A common mistake with one like this is forgetting that 1 there, and just having it look like this. So remember, if you divide y by itself, y fits into y just one time, so there will be a -1 there. And a way to check to make sure you've got the right factors is just try distributing it back out in your head, make sure that you get back to the original. Alright, for number 2, there's no common factor for this one, and it has 3 terms, it's a quadratic, so we can do the number puzzle. We're looking for 2 things that multiply to give us -14, but add up to -13. Those are -14 and 1. If this had a leading coefficient of 1, if it looked like this, I'd be able to go through and just write my factors. When I have a coefficient greater than 1, I have to use the box or grouping to figure out how that 2 splits between my factors. So I set up the box where I put 2x squared and -7 in. -14 and 1 are the things that combine together to give me this -13x. So since this has an x, -14 and 1 will both have x's as well. And then I looked for a common factor for each column and each row. So my factors here would be x minus 7 and 2x plus 1. Alright, same idea for this one. There's no common factor that I can take out at the start, so I'm looking for 2 things that multiply to give me 12, so 3 times 4 is where that 12's coming from, and then add up to 8. So that's 6 and 2. So I decided to set up the box and find common factors for each of them to get my factors there. Alright, for the last 2, this one doesn't have any common factors, but it is a difference of squares. Difference means subtraction, and squares means 2 perfect squares. So this would be x plus 4 and x minus 4. I just take the square root of each of those to get these. This one has a common factor of 4, so I would divide that out first, and then what's left over is 2 perfect cubes. So I use SOAP for that, and SOAP works whether I have a minus or a plus. SOAP just gives us the signs for each of these. So S stands for the same sign, so this will also be a minus. Between my next 2 terms would be the opposite sign, and then the last term is always positive. And then a common mistake here is forgetting to put the common factor. So just remember you factored out a 4 from everything, so that's still one of the factors that's listed here. Right, the last thing is a common mistake when you're working quickly in factoring is thinking that this is a difference of squares, but it's not. A difference of squares has to have subtraction. The reason why this isn't factorable is if I check, if I say the factors are x plus 4 and x plus 4, if I multiply this out, I end up with a middle term of 8x. So it doesn't give me just x squared plus 16, it gives me a middle term as well. Or if I were to try x minus 4 and x minus 4, well, the problem here is it still gives me a middle term of -8x this time, and that makes my last coefficient, in this case, oh sorry, that would be a plus. Alright, so the problem is the fact that it has a middle term. Alright, so for the lesson today, we're working on adding and subtracting rational expressions, and rational just means ratio, which is a fraction. So to help us with this lesson, let's just talk about very simple basic fractions first, and then use that process and apply it to more complicated ones that we're looking at today. So since adding and subtracting are counting operations, they allow us to count up in total how many pieces or things that we have. Those pieces, those things have to be the same size and shape in order to be able to do that. They have to be the same. They have to be common. So if I look at this here, I have a pizza that's been split into 6ths, and so I have 2 of those, and I'm adding 1 more because this is also split into 6ths. So altogether, if I count that up, I have 1, 2, 3 pieces altogether. So notice that when I add fractions, the denominator isn't changing. That just shows how big of a piece I have. The numerator is changing because I'm showing how many of those things I have. So even with subtraction, as long as they're the same sized pieces, so here they're 5ths, so if I have 4 of these 5ths and I take away 1 of them, there would just be 3 left over in the end. Okay. So we're going to apply this idea to simple fractions and then to harder ones that have variables. So the idea is, once again, we need a common denominator. So this process of these boxes, it's just a way of thinking about this. You don't have to do it this way, but it's how I'm going to show you some of the others as well. So if I look at factors for my first denominator, 2 doesn't break down anymore, so its only factor is 2. Same thing, 3 doesn't break down anymore, that's my second denominator, so its only factor is 3. So if I want to create a common denominator, I need to look and see if they have anything in common, and then use multiplication to make them the same. So this is missing a factor of 3, so I'm going to have to multiply that in. This one is missing a factor of 2, so I'm going to have to multiply that in. So I'm going to multiply my first fraction by 3, and my second fraction by 2. So 1/2 is the same thing as 3 over 6. 1/3 is the same thing as 2 over 6. If I reduce these down, they still are 1/2 and 1/3. The value hasn't changed, but now they're the same sized pieces, which means I can go into the circle and I can slice these into sixths now. Alright, so I can see that I have 1, 2, 3 sixths for 1/2, and I have 1, 2 sixths for 1/3. And so if I count up how many there are, there's 1, 2, 3, 4, 5 altogether when I add them. Or another way of saying that is I did 3 plus 2, which gave me 5, and then the denominator doesn't change because, once again, that just says how big of a piece or what kind of slice or shape I have. Okay, so that same idea applies even when I start working with more complicated fractions. And the way this lesson is structured is that it starts out with really simple ones and then they slowly increase in difficulty. So we'll just kind of build up your skills along the way. So if I look at factors for this first denominator, 4 breaks into 2 times 2, and then I also have an x there. 4 here breaks into 2 times 2. So if I check, so far they each have 1, 2, 2 2's, so they have that in common already, but this needs a factor of x. This one needs nothing. So I'm going to go ahead and multiply my second fraction by this x here. So I'll have 5 over 4x, and I'm taking away 3x over 4x. So as soon as I see they have the same denominator, they have a common denominator, I can rewrite this as one fraction. So same thing as we did up here, where they have a common denominator, so I'm rewriting it as one fraction where the denominator doesn't change, but I'm just saying how many of those things I have. And I had 5 altogether here, so for this one I'd have 5 minus 3x. Since these aren't like terms, I can't combine them together anymore, even though I could here, because these were like terms, which is where that 5 came from. So this would actually be my final answer. You might be tempted to cross out these x's, but keep in mind that if I have addition or subtraction, that all represents one number. So those things are connected to each other. I can't cross anything out unless this exact factor appears in the denominator. So this won't simplify anymore. That'll be my final answer for this one. All right, for the next one, if I start to look at the denominators, this has a factor of x, this has a factor of 3. So this one needs a 3, and this one needs an x. So I'm going to multiply my first fraction by 3, and my second fraction by x. So I'll get 6 over 3x plus 1x over 3x. And these have the same denominator, so I can combine them together now. Remember, this won't change because this is telling me the kind of size-shaped piece that I have that I'm counting up and seeing how many there are of. Alright, but in my numerator I'm doing 6 plus x. Alright, and once again, these are not like terms. I can't actually add them together. And once again, you might be tempted to cross these out and say that that's 2, and cross these out and say they cancel out. When I have addition or subtraction, so I have more than one term, that all represents one number. Versus this, 3 times x is one monomial, one term. This is 2 terms. I can't cross anything out unless this exact same factor appears in the denominator. Okay, so that would be my final answer for this one. Alright, so take a moment to try the last one. So pause the video, try it on your own, make sure you understand this process, and then you're going to come back and check your answer. Right. So if you did this correctly, you'd be factoring these as much as possible. So you'd get 3 times 2 times x for 6x. and you'd have 3 times y for 3y. They already have a factor of 3 in common, so this one needs a 2 and an x. This one needs that y. So I multiplied them in and got this. So for my final answer, once they have a common denominator, that won't change. What is changing is I have 5 y's, and to that I'm adding 2 x's. All right. So next example will be, once again, the same process, just kind of increasing the difficulty. So we're going to work on simplifying ones like this. And once again, we need to make sure they have common denominators. So notice that these already have a common denominator. So in that case, that won't change. And I would just show I'm doing 2x and I'm adding 5 to that. They're not like terms, so I can't combine them. And these factors are not the same, so I can't cross them out. That would be my final answer. This one I have a fraction, and this one I don't. So think about, if I have a whole number, if I divide it by 1, that doesn't change the value. And now I can compare those denominators. So in this first denominator, 2 times t would be my factors, and this would just be 1. So in that case, this is missing both 2 and t. I'm going to have to multiply them both in to create a common denominator. So I'll have 3t over 2t minus 8t over 2t. These are the same now, and that's not going to change. That just shows me what kind of piece or slice or thing it is that I'm totaling up. And then in the numerator, if I have 3 t's and I take away 8 of them, that's going to give me negative 5 t's. So notice these were like terms, and that can happen sometimes. If I check, notice that these are single terms, unlike these where I have 2 terms, they give me my number. This is just one single term. So I can actually simplify this more. In this single term, if I have a t and a t here, they have the same variable, so I can subtract their exponents when I'm dividing. So that tells me these are actually going to cancel out. My final answer here would be negative 5 over 2. All right, so as we work on more challenging ones, the process will be the same, and so we're always going to start by looking for the least common denominator. And that might involve factoring first. And to create that, we'll compare all of their factors and we'll multiply each fraction by whatever factor it still needs in order to become the common denominator. From there, we're going to be adding or subtracting the numerators, and then just simplifying if it's possible. And it might not always be possible. So for this first one here, notice they're already factored for us. Ways to tell that something is factored is if your variable has an exponent of 1, that makes it linear and it won't break down anymore. So I know that this has a factor of x minus 4, this is a factor of 2, and x minus 4. And if it helps to remind yourself, when I have more than one term, that still just represents one whole number. So it might help to put parentheses around it to remind yourself of that. So I can see they already have that factor in common, but this is missing that 2 that the other one has. This is missing nothing. So I'm going to multiply the first fraction by 2. And so 2 times 7 will give me 14. You can leave the denominator factored. If you want to multiply it out, that's totally fine. You'll get the same answer. Just be careful with the multiplication if you do that, if you choose to do that. I'm always going to leave mine factored because I find it easier. All right, and to that I'm adding an x over 2 times x minus 4. So now that I can see they have a same denominator, a common denominator, what I'm really doing is 14 plus x in the numerator over that denominator. All right. And once again, you might be tempted to start crossing things out, saying, oh, I can divide 14 by 2, but remember, terms that are more than 1, where they're separated by addition and subtraction, that represents one number. So unless this exact factor is in the denominator, I can't cross it out. So this would be my final answer. If you like writing the x first, then you would write it as x plus 14 over the same denominator. So either of these would be correct. All right, so pause the video, take a moment just to try these two underneath to make sure that you're understanding. If you like using kind of this table or this box to compare the denominators, you're going to have to draw your own. So get used to that. I won't provide them on a quiz or a test, so it might be helpful just to practice that now. So pause the video, try it out, and then come back to see if you got them right. All right, so when I compared these, they were already factored. So this one was missing this factor of 3. This one was missing that factor of x plus 1. So I started by multiplying those in. Be careful of the subtraction. This actually means minus this whole fraction, minus this whole thing. So when I rewrote it, I did 30 minus 2 times x plus 1 as a reminder to myself that I have to distribute that minus sign to both of them, which is going to make that a negative 2x and a negative 2. And if I combine my like terms here, that's going to give me 28. Right. And you can leave the denominator factored. You could leave it as 3 times the quantity x plus 1, or if you choose to multiply out, that would also be correct. So either one works. So the denominator can look like this or like this in the final answer. But definitely check your numerator. It should be exactly like this. So for the second one, I compared them. They don't have any factors in common, so this one needs m plus 2 and this one needs m minus 3. So I multiplied that in to begin with. Right. From there, I said I'm going to be adding this to our first one. The denominators are the same, so that's not changing. And when I combine like terms, 3m's plus 5m's give me 8m's. Positive 6 plus a negative 15 gives me negative 9. All right, so once again, same process, just increasing the difficulty. So we have 2 more examples that we're going to go through. The only thing that makes these more difficult is now you have ones that you're going to have to factor. So double check and see, do your denominators factor anymore? I can see that this one doesn't because it's linear. Its x has an exponent of 1. If it helps, maybe put this in parentheses to remind yourself that represents one number. This is a difference of squares. So if I take the square root of each of those, that'll give me x plus 2 and x minus 2. So they already have this first factor in common. This one is missing an x minus 2. So I'm going to go ahead and multiply that in. So I'll end up with 4x. You can write the denominator either in factored form or multiplied out. I'm going to write it in factored form just because I prefer it that way. And if I distribute 3 to each of these, I'll get 3x minus, 6. All right. So be careful of subtraction. It's easy to make a mistake here. This means minus both of these terms, minus the whole thing. So when I'm rewriting this, now that I see that they have a common denominator, I'm going to have 4x, but I'm subtracting 3x as well as negative 6. So those signs for those two things are going to change. If you think you're going to forget, maybe put it in parentheses so you can remember to distribute out the minus, or just give it to each of the terms now, which would make this a negative 3x, and that would become a positive 6. But I'll show that in a second step, just in case it helps you. So that's going to become minus 3x, and a negative times a negative becomes a positive. All right, and I do have some like terms here. I'm going to combine these together. So altogether I have x plus 6 in the numerator, x plus 2, x minus 2 in the denominator. And none of these factors are the same. I can't cross them out, so that would be my final answer for this one. All right, so go ahead and pause the video, try the problem on the next page, and then come back just to double check and see how you did and make sure that you got it right. All right, so on the next page, sorry. Okay, that stupid little orange thing is always in the way. Okay, so if you compare the denominators here, you had a difference of squares again. So that denominator becomes x plus 5 and x minus 5. This one is just a y minus 5. And they already have that in common, so this one needs a y plus 5. So I started by multiplying that to both of them. Just be careful, remember this means minus both of these, minus this whole thing. So once they have a common denominator, I can rewrite it as one fraction where I have y plus 8 minus this entire thing. So I'm going to have to subtract each of those terms. So it'll become a negative 3y and a negative 15. When I combine like terms here, y minus 3y gives me negative 2y, 8 minus 15 gives me that negative 7. Okay. Alright, so one last example. Once again, the process isn't any different. The only thing is I just gave you more things to factor here just to review factoring. So my denominator here has 3 terms, and the leading coefficient is 1. So if I do the little puzzle, I'm looking for 2 things that multiply to give me 4, but then add up to be this b term of 4, and that would be 2 and 2. Since it has a leading coefficient of 1, these are automatically my factors. If this was bigger than 1, I'd have to do the box or grouping afterwards to figure out how it splits up. And we saw that in the warm-up. So my 2 factors here are x plus 2 and x plus 2. This is a difference of squares, so that's going to be x plus 2 and x minus 2. So they already have one factor in common, but this one is missing this x minus 2. This one is missing a second x plus 2. So I'm going to start by multiplying that into each of them. Alright, so keep in mind that when I'm multiplying a binomial times a binomial, like I have right here, you might want to set up the box or do FOIL for that. So I'm going to set up the box just kind of off to the side so we can try it out. So x minus 2 times x plus 1, so that'll give me x squared, negative 2x, positive 1x, and then negative 2 times 1 gives me negative 2. So the new numerator for this fraction would be x squared. These are like terms. When I combine them together, a positive 1x and a negative 2x will give me a negative 1x, and then negative 2. So that's the numerator for that one. The denominator, if I double check, I multiplied it in an x minus 2, and then it already had 2x plus 2's when I factored it. And just to write less, if this factor appears there twice, it has a multiplicity of 2. I can write it with an exponent of 2, just to show that it's there twice. Or you could write it out as x minus 2, and then x plus 2 and x plus 2. Same thing. Alright, so that's the first one. I'm taking away, and if I distribute here, I'll have a 2x plus 4 in the numerator. The denominator, I have an x minus 2 from that. The other difference of squares gave me another x plus 2, and I multiplied one more in. So there are 2 of those x plus 2's. So I can show that using an exponent of 2, or you can write it twice, whichever you prefer. It means the same thing. So now that I see they have a common denominator, I can rewrite it. Just keep in mind I need to make sure I'm subtracting this entire thing. So that's going to be minus both the 2x and the 4. So it might help to put it into parentheses to remind yourself of that. And I have a common denominator, so I'll rewrite that. Alright, so if I distribute out, that's going to change the signs of these. So a minus to 2x will make that a minus 2x. A minus to 4 will make that negative 4. So notice I've changed the signs of them, so I changed this to adding the opposite of them. So as I start to combine like terms, I'll have an x squared. There's nothing to combine with that. Negative x and negative 2x will give me negative 3x. Negative 2 and negative 4 will give me negative 6. Alright, and that would be my final answer. Alright, so at this point, take a moment just to pause the video. You can use this as your example, but try the 3 problems afterwards just to make sure you're understanding. Something like h, so problem number h underneath, even though it has 3 fractions, would work the same way. I'm just going to scroll this up a little bit to show you. In that case, if you like doing this table to help you, you would just make 3 spots for it. and you'd just be comparing each of the denominators. This one has a 3, this one has a y, and y squared would be y times y. So looking at them, you'd see, okay, these two already have a y in common, but this one needs a second y. These two don't have anything in common, so this needs a 3, and this one needs these two y's. Alright, so now if we compare these two, this one already has one y, but this needs a 3. Okay. So yeah, pause the video at this point, try these 3 problems, and then come back to see how you did. Alright, I'll kind of show them one at a time. Alright, so I started by factoring this denominator using the puzzle, and I got a factor of h minus 4 and h plus 3. Alright, and then the 2 doesn't need factoring at all, so these need a 2, and then this one needs these two terms, or these two factors. And to save myself a little bit of time, I just remembered that if I multiply these together, I'll get this original thing here. So if I multiply these together, that gives me h squared minus h minus 12. So I know that that's what I'm multiplying with this 3 here. So if I multiply 3 to h squared, that's where that came from. Or if you use the box, you'd multiply this out and you would get h squared minus h minus 12. Okay. Once they have a common denominator, I can rewrite them. Keep in mind this is minus this whole thing of 10. And so when I write it out, I have 2 like terms that I'll combine together, which is where that negative 46 came from. Alright, so we talked about the denominators for h, and so I'd just be going through and multiplying each of them by the things they're missing. So this is missing 2 y's. Y times y is also y squared, is another way of saying that. So I'll have 2y squared, and then in the denominator I'll have 3y squared. If I multiply the second fraction by 3y, 1 times 3y is 3y, 3y times y is 3y squared. So far they have a common denominator. Good. The last one needed a 3, so 3 times 5 gives me 15, and 3 times y squared will give me 3y squared. Now that they all have the same denominator, I can rewrite this where I'm combining those things together. And since none of them are like terms, it would just stay like that. Alright, for the last one, if we compare them, this has a common factor of 4. So I'm going to start by factoring that out. So I'll have 4 times 5v plus 2. This is a whole number, so I'm going to put it over 1. So its denominator is a 1. And so it's missing this. It needs both a 4 and a 5e plus 2. Alright, so I don't need to multiply anything into the first one. I left the denominator factored. And then I show that I'm multiplying 2v with 4 and also with 5e plus 2. And you can multiply in any order and get the same answer. So you could distribute the 4 to both of these first, and then distribute 2v to both of them. You'll get the same answer. I just chose to go from left to right. So 2v times 4 gives me 8v, and then 8v times the other two terms gives me 40v squared plus 16v. So that's where this part of my answer came from. The second part is that first fraction there, 6v plus 1. And then I just looked for common terms, like terms, to combine together. So 40v squared, those two combine to give me 22v, and then I have that positive 1 in the end. Alright, so that is it. If you do need help with this lesson, feel free to come to Warhawk Time, or if you want to stay after school sometime, just come chat with me and we'll arrange a time to make that happen. Alright, awesome.